Okay, in this video we will prove the explicit formula of the largest index of the largest Fibonacci number. Let's see the problem. Given xk is Fibonacci squares with x0 is equal 0 and x1 is equal 1. Suppose that n is a natural number and k is the largest index such that xk is less than or equal n. We want to prove that k is equal the floor value of this logarithm quantity. I got this problem from Number Theory for Mathematical Contest by David Santos. If you want to try, just pause or skip this video and you can check for the solution later. Okay, let's begin the proof. First, we need to remember what is the definition of the floor value of x. The floor value of x is the largest integer which less than or equal x. Since k is equal the floor value of x, we have k is less than or equal x. Since k is the largest, we have k plus 1 is greater than x. So, if we want to prove k is equal the floor value of this logarithm quantity, we need to prove the logarithm quantity is between k and k plus 1. By the property of logarithm, we know that log b over log a is equal a log b. So the logarithm quantity becomes this new logarithm quantity. If we use all of the quantities in this inequality as the power of 1 plus square root of 5 over 2, we have this inequality. Next, let's use this logarithm property to the middle logarithm quantity, with a is equal 1 plus square root of 5 over 2 and b is equal n plus half times square root of 5. So we get n plus half times square root of 5. Therefore, we get this inequality. Multiplied by 1 over square root of 5 and cancel out the square root of 5 in the middle, we have this inequality. So, if we want to prove the problem, we just need to prove this last inequality. Let's keep in our mind our purpose. And we start with proving the first part of the last inequality. One of the proving techniques to prove an inequality is by moving backward. Now, we subtract both sides with this quantity. We do this because this entire quantity is actually the Binet formula for Fibonacci number. For detail of the formula, I put it on the description. Next, let's focus on this red quantity and name it as AK. The absolute value of AK is equal to this one. Since 1 over square root of 5 is less than half and the other is less than 1, so we have the absolute value of AK is less than half. Open the absolute bracket, we have half plus AK is greater than 0. But from the equation, we have xk is less than or equal n. Since n is equal n plus 0, and 0 is less than half plus ak, we have xk is less than n plus half plus ak. Until here, we have proved the inequality one, which is the first part of our purpose. Finally, we are going to prove the second part of our purpose. Again, we will use backward proving technique, and the proof is similar with the first part of our purpose. Subtract both sides with this quantity, so we get the Binet's formula for Fibonacci number, which is equal xk plus 1. Again, let's focus on this red quantity, which is ak plus 1. From the proof of the first part before, we already know that the absolute value of ak is less than half for every natural number k. Of course, it's still satisfied if we add 1 to the k. And open the absolute bracket, we have ak plus 1 is less than half. Added by half to the both sides, we have ak plus 1 plus half is less than 1. Since k is the largest index such that xk is less than or equal n, which means xk is the largest Fibonacci number that less than or equal n. So we should have xk plus 1 is greater than or equal n plus 1. Since 1 is greater than ak plus 1 plus half, we have xk plus 1 is greater than n plus half plus ak plus 1. And then the proof of equation 2 is done. Which means we already proved the second part of our purpose. Which means we already proved k is equal the floor value of the logarithm quantity. And there we are done.